So in this video, we are going to discuss about a low pass filter. It is nothing but a passive filter. Okay, and because what is passive filter means it can be designed using R, L, and C. Okay, so in this video, we are going to use only RC. Okay, so this is also called as attenuating circuit. Okay. So I told you here we are going to use only R and C. Okay, R and C. So this is your input. Okay, and here come you are taking a output. Okay, so and the current flowing through this one is I. Okay, so I can write V naught. What is V naught? V naught is equal to 1 divided by C integration of I of t dt, right? I can write like this. The current flowing through the capacitance, I can write like this. What is I of t? I of t is nothing but I is nothing but VA of t divided by R. Okay, so I can substitute here 1 divided by RC of VA of t dt. Okay. So you can see my output voltage is nothing but the integration of the input voltage. Okay, so output is proportional to the integral of input voltage. And also you can see whenever the frequency increases, okay, whenever the frequency increases the XC is nothing but 2 pi F, okay, FC. So whenever the frequency increases, the XC start to decrease. So if it is decreases means it becomes short circuit. Okay, it becomes short circuit. So if it is short circuited, when there is an increase in the frequency, the V naught will goes to 0, right? Therefore, V naught will goes to 0. Okay. So if I draw the circuit, if I draw the graph between my, it will pass only the low frequency value. Whenever it reaches the cutoff, that is FH, it will start to decrease. Whenever there is increase in the frequency, the gain started to reduce. Okay, so that is why it is called as a low pass filter. Okay, so ideal cases whenever this is a ideal block diagram. Okay, so whenever it reaches it is for low frequency, that is below FH, it will pass all the frequency, after the FH value, it will not pass anything. So this is called as pass band, and this one is called as stop band. Okay, so this is the ideal low pass filter. Okay, so here I can write V naught is equal to 1 divided by SC by 1 by SC plus R into VA. This is also I can write like this. So V naught by VA is equal to 1 divided by 1 plus R SC. Okay, so this is nothing but H of S. So the H of S is nothing but 1 divided by 1 plus j omega RC. Okay, I can substitute S is equal to j omega. So if that is the case, I can write 1 plus j 2 pi F RC. Okay, so I can write H of S is equal to 1 divided by root of 1 plus, okay, 1 plus 2 pi F RC square. So this I can write it as H of JF. 1 divided by root of 1 plus f by fh the whole square, where fh is equal to 1 divided by 2 pi rc. That is measured in terms of hertz. Okay. So let us discuss what happens when the VA is nothing but a square wave. Okay. The LT VA is nothing but a pulse input. Okay, pulse input. So pulse is nothing but this is nothing but your pulse. Okay, if this is VA, so this is a pulse signal. Okay. So I can write VA of t is equal to V from 0 to TP, right? And it is 0 for the rest of the value, right? So this is a signal which we are giving it to this circuit. Okay. So what will be the response? That is what we need to see. Okay. So we know that V naught of t is equal to V of V naught of infinity minus V naught of 0. Initial value minus V naught of infinity into e power minus e power minus t divided by r's. Okay. So this is a general form, general equation. So in that they have to substitute this value. So initially you can see but this is a case the output will start from 0, right? So V naught of 0 is nothing but 0, and V naught of infinity tends to reach V, right? So you substitute it here. So if I substitute V plus 0 minus V into e power minus, so I'm going to looking for the time of 0 to t up to TP. So this is the time, that is t is equal to TP. Up to TP, the input voltage is same, so I am going to substitute TP by Rc. Okay. So what is V naught of t? V naught of t is equal to V minus V of e power minus TP by Rc. So this is nothing but V, if I take it common, you will get TP by Rc. Okay. So if this is the input signal which I am giving, so the output I am going to get it as V naught. Okay. So initially it is 0. Okay. Initially it is 0. Right. That is what I have already mentioned. Initially it is at 0, and finally it is going to reach the value called Vp. So this is nothing but 1 minus e power minus TP by RC is nothing but an exponential signal. So it will reach nothing but a point called Vp. Okay, at t is equal to t. Okay, so this value is less than my V. Okay. So if bye. I can also obtain the signal like this. Okay, we are not. This is your B, right? This is your P, and this is your TP, and this is T. So I can obtain the signal also like in this manner. Okay. So this is also possible. When RC value is less than T. Okay. Here, when RC value is greater than TP. That is, RC is a circuit we are using, right? This RC. So RC is nothing but a time constant value. This is measured in terms of seconds. Okay. So this is also in terms of seconds. Okay. So I can relate RC and TP. So if RC value, that is if it is 1K and this is 1 micro, and if this value is less than, if this value is greater than the value of TP, that is this value, then you will obtain the signal like this. Okay. So if RC value is less than TP, you will get you will obtain the signal like this. Okay. So there is also one more condition where TP is equal to RC. So you can check the condition, the similar condition in your lab section. Okay. What happens when RC is equal to TP? Okay. So the next condition is what will happen after when T value is greater than T. Okay. So for T value is greater than T, it is nothing but 0. Okay. So initial value of V0 of 0 is nothing but Vp, right? And after infinity, it goes to 0. Anyway, it tends to 0, right? So I can substitute V0 of T is equal to 0 plus Vp minus 0 into e power minus the time is Tp minus T, right? Tp minus
That's about it. Out. You know, it's giant. And what about
T minus T, sorry.
the need I use the bulk and you didn't up one other. Helen is I mean,
This is higher value, this is lower value. Divide by Rs. So if I substitute, I will get Vp of e power minus T minus Tp by Rs. Okay. So here this tau is nothing but RC, that is nothing but a time constant.
since all the deliver off me.
So
Loud. It's like think of I'm but
after reaching this Vp, it start to decrease. Okay, it start to decrease in this manner. Okay. The similar case it is for RC is less than Tp. Okay.